question 7 reads, a pool initially contains 1,385 cubic feet of water. A pump begins emptying the water at a constant rate, emptying, of 20 cubic feet per minute. Which of the following functions best approximates the volume Bt in cubic feet of water in the pool t minutes after pumping begins, for t is greater than or equal to 0 and less than or equal to 69. Because of this word right here, constant rate, I'm led to assume that it is about linear equations. And we all know that linear equations are in the form y equals mx plus b, or c, depending on where you are in the world. And m is our slope, and b is our y-intercept. Well, in a real-life application like this question, the slope is really the rate of change. And the y-intercept is the starting value, what we start off with before the change occurs. And in this equation, in this example, our starting value, it says a pool initially contains 1,385 cubic feet of water. And so that's our starting value. And if you look at the answer choices, all of them have the y-intercept correctly. They've got it all correct in that domain. So now that must mean the rate of change is different for all these equations, right? And so if you look back at the question, it says a pump begins emptying the water at a constant rate of 20 cubic feet per minute. Well, emptying must mean a decrease, right? Whatever we started off with, it is slowly decreasing at a constant rate. And what is that amount that it's decreasing by? Well, it says it right here, 20 cubic feet. And so if I reconstruct it, it's going to be our starting value is 1,385 minus 20t, right? Because it says 20 cubic feet per minute, right? And so the minutes are variable, and any number between 0 and 69 will be true for this equation. And so our answer choice that matches up is going to be A. This section really, this part here, can throw people off right now. This is just a restriction for T and doesn't really have any bearing on the answer choices. So do not fall for B or D especially.